All right, looks like it's about 10 o'clock. Appreciate everybody joining us for today's coffee break. My name is Aaron Morris. I'm a sales engineer with Long in Colorado Springs office. And today we're going to be discussing the ASHRAE 62.1 and specifically the indoor air quality procedure. So ASHRAE standard 62.1 defines acceptable indoor air quality. It's been, I think it was published in 1981 and adopted into code in 2000, I believe. But we recently got an update in 2022, which provided some useful updates, especially when it comes to using the indoor air quality procedure method. Right. So the standard provides 3 methods that we can use for determining the amount of ventilation required to provide good indoor air quality. There's the natural ventilation method, which really just uses infiltration through your building, through openings in your building to ventilate your building. So not the most efficient way to provide good indoor air quality. And then the ventilation rate procedure or ventilation method, which is by far the most popular method used in commercial building designs. Which is going to be kind of a rule of thumb amount of outside air, CFM per, or I guess occupants per square footage based on the usage of that building, the type of building it is, and then CFM per square footage to come up with that ventilation requirement. And then there's the indoor air quality procedure, which really targets specific contaminants and lets you use technologies to address those contaminants to come up with the right amount of ventilation required to achieve your indoor air quality. I mentioned some standard updates to the ASHRAE 62.1 standard. So you can see here the requirements on the left really haven't changed since the standard was published. Right, we want to, using the IAQ procedure, identify the contaminants of concern, set concentration limits for those contaminants, validate that we've addressed those contaminants using the efficiencies of the air cleaning methods that we're implementing, and then calculate the ventilation required based on those values. But when the standard was published, there was very little data to work off of, so everything was really just left up to the engineer of record, which created some risk for the engineers, trying to implement this method. But in 2022, we got an update that provides definitions of 14 compounds, which are contaminants of concern, and provides design limits for each of those contaminants. And then provided objective IAQ testing and efficiency test standards, which are defined in ASHRAE 145.2, that allow manufacturers to test their products and quantify the efficiency of their products against various contaminants. So now there's a lot more information that we can use to use the IAQP method and determine our ventilation required. What are some of the advantages of using the IAQP method? Enhanced energy efficiency. When we go through this process, you can reduce the amount of outside air required and therefore reduce the energy required to treat that outside air. You can improve the indoor air quality even with less ventilation because you're using a strategy to specifically target the contaminants of concern. And it could provide design flexibility. If you have a building with a large ventilation rate, You might need a large centralized DOAS unit, and it might be difficult to find a place to fit that equipment and fit the ductwork from that equipment to all the spaces in the building. So by using IAQP, you can treat the contaminants that are of concern and reduce the ventilation rate, and therefore reducing your DOAS unit sizing, and maybe find a way to fit it into the building. Cold climates like ours becomes pretty obvious. You know, all that outside air we bring in might have a design condition of 0 or below. You know, so we got to heat that air up in the wintertime. So less outside air, less heat required, less energy used, right? Something important to mention here is that the IAQP method can be used in conjunction with demand controlled ventilation. So you could use the IAQP method to target those contaminants, reduce your ventilation, minimum ventilation required, but still have the ability to open up your outside air damper and react to real-time feedback from CO2 sensors in the building. So as your occupancy changes, you can dilute that CO2 or ventilate that CO2. So typical pollutants, contaminants that we're going to consider. So CO2, I think people are used to thinking about and deciding if they need a demand controlled ventilation strategy. But we're also going to be looking at VOCs like formaldehyde, benzene. Formaldehyde being a big one. That's a VOC that originates from various building materials and furnishings that go into a new building. So LEED pays attention to those VOCs and is really looking for materials that have lower VOC off-gassing, but we also have products that can target those VOCs and treat them so that it improves the indoor air quality. We'd also be looking at particulate matter, and depending on the usage of your building, ozone, carbon monoxide, nitrous dioxide could be a concern and could be something we'd want to find a treatment strategy for. When we look at how to implement IAQP, you have to look at the usage of your building. So, a lot of buildings are different. I guess you wouldn't treat a gym the same as you would treat, say, like a data center. So a data center is an interesting example where you have a large square footage of area, but very low occupancy. So if you use the ventilation rate procedure, it's going to have you assume a certain occupancy, and your ventilation rate is going to be higher than it would be using the IAQP method, where you would just really, treat the contaminants of concern, which is kind of just you just have server racks in an empty room. So maybe some ozone or something you might want to treat, but you'd be able to lower that ventilation rate and therefore increase the efficiency of that system by using the IAQP, similar to maybe like a conditioned self-storage unit, where you're not really going to have occupants in that space, right? And that would be different than a gymnasium where you will at times have full occupancy and have a large ventilation requirement, and maybe you use that with a demand controlled ventilation strategy. But you could otherwise use IAQP in that gymnasium to reduce your minimum ventilation rate. So when that space is not occupied, you're bringing in a lower amount of outside air and providing the most efficient system. You need to identify the contaminants of concern and set concentration limits, which those guidelines are in the ASHRAE standard now. And then you need to model a scenario for your building based on the treatment strategies that you're going to implement. So we'll take a look at that, how you could model that using spreadsheet calculation tools that are available. On the left, that flow chart we're looking at actually comes from ASHRAE's standard 62.1 user manual, and kind of walks you through the thought process and the flow using IAQP for your building. So that standard 62.1 user manual is definitely a helpful tool. It's available for purchase through ASHRAE's bookstore. If you're a member, you'll get 25% off of that purchase. But then the manual goes step by step into all three methods. But really, with the update provides good guidance on using the IAQP method, and then also comes with access to ASHRAE's 62.1. They call this the 62.1 MZ calculator. So this is a spreadsheet tool developed by ASHRAE that comes with that user manual, and it provides you with data tables on separate tabs. They give you the values of the max values, concentration limits for various contaminants, and gives you outside air contaminant levels based on different cities. So lots of useful information. And then on this page, you would plug in your inputs, and it would help calculate by zone. So you can kind of see on the right there, you can have that can go off to the right as far as you need to have multiple zones on, say, like a VAV system, and help you calculate by zone the ventilation rate using your efficiency values based on the filtration or air purification methods you're using to treat your contaminants of concern. Their calculator is not the only one you can use. Several manufacturers have their own. So this is an example, and you can see it looks a little simplified from Casper, which is one of the manufacturers that Long partners with. So you can see here it lists those 14 contaminants, actually has a few extras, and lists the threshold values for those contaminants based on the EPA standards, and then already has the efficiencies for Casper's product on how it treats each one of those. And so you can plug in your inputs based on, this would be a single zone, right? And you would do one of these per zone. And it just gives you a simple yes or no off to the right there of whether you're meeting ASHRAE standard 62.1 acceptable levels. So we have lots of tools available to us, and lots of manufacturers we partner with. I mentioned Casper. Their product is a patented UV light that converts air to hydrogen peroxide, which is then used to disinfect your airstream and surfaces, both in your ductwork and in your space, depending on how you implement it. We also partner with American Air Filtration Products, which has a full range of particulate filtration, HEPA filters, gas phase filtration, and carbon activated filters. So it can be used depending on which contaminants affect your building. UVDI manufactures intense UV grids that can be sized to meet the airflow velocities through your air handler or duct systems, and sized intense enough to eliminate airborne viruses, bacteria, mold, as they're traveling through your air system. And Atmos Air offers bipolar ionization, which creates positively and negatively charged ions in your ductwork, in your equipment, or in your space. Those ions can interact with different contaminants and render them neutralized to purify the air in the space. And then sorbent ventilation technology. So through Daikin, Daikin has partnered with a sorbent ventilation technology to integrate their technology into their packaged rooftop systems and air handling units. So with the sorbent ventilation, various compounds like carbon dioxide, formaldehyde, Other VOCs and inorganic compounds are trapped on the sorbent filtration media, and then through a regen process are exhausted out of the airstream. And the cleaned return air is then returned into your supply tunnel and delivered into your building. And again, all these products I mentioned are tested to ASHRAE 145.2 so that we have quantified efficiency levels that can be plugged into the calculation tool to help determine if you're meeting the indoor air quality per ASHRAE standard 62.1. So kind of in summary, reasons to use the IAQP method would be enhanced energy efficiency, improved indoor air quality. You can use the IAQP method in conjunction with demand control ventilation strategies. The ASHRAE 62.1 manual comes with the ASHRAE 62MZ calculator spreadsheet that you can purchase on the bookstore. Or there are other manufacturers' design tools available to help with that if you do not have access to the ASHRAE calculator. You can reach out to your long salesperson, and we partner with several manufacturers that can help us implement different technologies to implement on an IAQP method strategy, trying to reduce your ventilation requirement and improve your indoor air quality. So appreciate everybody joining us and hope you'll join us again next week for the ultra low NOx combustion technology topic with Bobby Henderson and Hikmet from Weishaupt Boilers. So please join us next week. We got a choice of a $100 Meow Wolf gift card, a Bluetooth karaoke machine, and a Let's Assume I'm Right desk sign. So please reach out to your long salesperson and let them know which prize you would like to claim. Thank you, everybody, and have a good day.